A point source of light, yes, is placed on the axis of a lens of focal length 20 centimeter as shown. A screen is placed normal to the axis of the lens at a distance x from it. Treat all rays as paraxial, and the four options are here. Well, I read all these options later. First of all, I'm going to explain this picture, what they have given. The position of the lens, it is here, whose focal length is at 20 centimeter. The aperture is 2 centimeter. So this diameter of the lens is 2 centimeter. And here is the point source S, which is placed 25 centimeter to the left of the lens. And this is the screen. Okay, so this is the screen. They are saying the screen is at a variable distance x from the lens. So in this part of the question, they are saying just alter the position of the screen and look into the nature of the image as the function of intensity. Okay, so then you have to choose the best choice. Well, you must be careful about this picture, so you have to keep this in mind, right? So next, what I'm going to say you is this picture. See this picture. Let me say the focal length, as they said, it is 20 centimeter, no doubt. And here is the position f1. That is the first principal focus. That is to the left of the lens. So exactly at the same position, if we place the source, no, it should not be, because it should be placed at 25. But I'm assuming if we place it at the point f1, then the light rays which are entering into the lens simply go paraxial. Okay, so simply go paraxial. That means that they never meet one another, so it extends to infinity. So no image will be formed. If you place a screen here, right? If you place a screen here in this position, anywhere, so you will get light like this, right? So the light is always of this much width. It's of constant intensity. Okay, so this much light you always get. But now the question is something different. They are placing the source beyond f1. Okay, so f1 is at a distance 20 centimeter from the lens. Okay, so the point source S is at 25 centimeter from the lens. It should be beyond f1 to the left. In this situation, this boundary is illustrating the screen. So then the light from the source simply enters into the lens and converges. So this is a converging lens. The light should not go away from the principal axis. It should bend towards the principal axis, and definitely the light ray will go like this. If you do the calculation, 1 by V is equals to 1 by F plus 1 divided by U. So making the substitutions like this, So this is 1 divided by how much? Which is 20 centimeter, plus 1 divided by this is minus 25 centimeters. So using all conventions, so you will get, so this is V. Okay, so you will get V is equals plus 100 centimeter, plus 100 centimeter, that is position of the image. So you get position of the image. That means here will be the position of the pointed object, which is here, which point source. So the image is here, which is at 100 centimeter. So clear image. Okay, so clear image is here. That means if you move this screen from this position to this position, this is x, right? So this is x. So as you move the screen here, so movement. So if you move the screen, definitely this circle right? This circle reduce in size, it shrinks. Okay, so once this size shrinks, the definition of intensity is what? So intensity is nothing but intensity of light is nothing but intensity is nothing but energy per area. Otherwise, I say it is a power per area. It is better. Power divided by area. This is a good illustration. So watt per meter square. So definitely you should explain this intensity in watt per meter square. That is intensity. So that means once you go from left to right, you move this screen from left to right, this area covering the light covered area, so that will shrink. That means area decreases. The power of the light remains same. So power of the light remains same. So it is constant. Power of the light is constant. That means numerator, that is power is fixed. This is constant. And when the area decrease, the intensity increase, right? So when the area decreases, intensity increases. That means once you move from left to right, when you take this screen from left to right, intensity increases. Intensity increases and becomes maximum at this point, because here is a point, right? All light energy is converges into a point. That means the intensity will be maximum here. So definitely, so maximum intensity will be obtained at 100 centimeter. This is correctly said somewhere in the question. So well, so we see these options. Option A says as x is increased, that means screen moved from zero intensity continuously decreases. That means, so when you move the screen from x is equal 0, x is equal 0 is here, from x is equal 0 to x is equals infinity. So what should happen? So he says when you move the screen away from the lens, intensity continuously decreases. No, so it is not continuously decreases, right? See, once you observe this picture clearly, so when you move from left to right, intensity increases, right? It becomes maximum. Once you go beyond this line, this point, again intensity decreases, because the area which is occupied by the light, say here somewhere, it is more, and it is more, still more, right? So the area increases. That means intensity decrease beyond this 100 centimeter. So till 100 centimeter intensity increase, and beyond 100 centimeter intensity decrease. So that means option A, what it is saying is wrong. Continuously decreases. No, it is wrong. So option B is as x is increased from zero intensity, first intensity increases, then decreases. It is right, right? So till 100 centimeter intensity increase. So it is right. So then decrease. So beyond 100 centimeter intensity should decrease. So that means this option B is right. Option C says intensity at the center of the screen for x is equals 90 and x is equals 110 centimeter is same, right? So 90 and 100 centimeter, where actually it appears. So 90 is the centimeter is here, it is 90 centimeter, and 110 centimeter is here, right? This is 110 centimeter. So these 2 points, you know, 90 centimeter and 100 centimeter are at a equal distance from 100 centimeter. That means they should be represented by the circle of light. This is the circle of light of equal widths. Of equal widths. That means the intensity at these 2 points, 90 and 110, should go same. That means what he is saying in option C, intensity at the center of the screen for x is equals 90 and 110 centimeter should be same. It is right. So then option C is right. So let us look into option D. Radius of bright circle obtained on screen is equal to 1 centimeter for x is equals 200 centimeter, right? X is equals 200 centimeter. The circle of light should be 1 centimeter radius. What he is saying. So let us see. See this. What what actually we are having, the light is entering into the lens, and light is converging at this point, and beyond which again the light appears to diverge. Okay, so the distance from here to here is 100 centimeter, and from here to here, say it is 100 centimeter, then it covers, right, then it covers 200 centimeter in total. So from the lens to this point, so we are having a distance of 200 centimeter. So it's exactly the same width of the lens, right? So this width is exactly the width of the lens. The aperture of the lens, which is said in the question, is 2 centimeter. See, this width is 2 centimeter. That means in this picture, if we say this width is 200 centimeter, then this width should be 200 centimeter. I mean 2 centimeter. This width. So that means the diameter is 2 centimeter. How much should be the radius? So radius should be 1 centimeter, right? So radius should be 1 centimeter. That means in this option, radius of bright circle obtained on the screen is equal to 1 centimeter for x is equals to 200 centimeter is also right. That means the correct options are option B, option C, and option D. And all these three options are right.